We are continuing with the reflection. Here the question is, use graph paper for this question. Take 2 centimeters equal to 1 unit along both the axes. Now scale is given to us. ABCD is a quadrilateral whose vertices are A, B, C and D. They are given. He says reflect quadrilateral ABCD on y-axis. So let's reflect this quadrilateral on y-axis. So I have reflection of point A along y-axis. 2 and 2 will give me A dash, and when I am reflecting a point through y-axis, the sign of x coordinate changes. So it is minus 2 and 2. Similarly, I am reflecting point B, which is 2 and minus 2. So this will give me B dash as minus 2 and minus 2. Then reflecting point C, which is 0 and minus 1 along y-axis. So x coordinate will change. So it will give me C dash, and C dash will be 0 and minus 1. So it will be invariant. There is no change when you have reflected this point along y-axis, right? So along y-axis, if you are reflecting point C, it is invariant. It may not remain invariant when you are reflecting it along x-axis or along origin. Then D, okay, reflection of point D, which is 0 and 1, will be again same D dash 0 and 1, right? Because no change, it's invariant. Okay, then he's saying write down the coordinates of A dash and B dash. You have written. Name 2 points which are invariant under above reflection. You know that C and D, right? So you can write C and D. You can see this from the graph also. C and D are invariant. That means they have not changed even after they have been reflected along y-axis. Okay, then name the polygon A dash, B dash, C and D. Now this we can do only when we will plot the points. Okay, let's plot these points. The scale is given. He said he's saying 2 centimeter equal to 1 unit. So we have taken 2 centimeter equal to 1 unit. So we will write here scale first. So along x-axis, 2 centimeter equal to 1 unit, and along y-axis same scale along both the axes, 2 centimeter equal to 1 unit. Sometimes you are given different scales also. Along y-axis you may have to take different scale, or along x-axis you may have to take a different scale, or you can choose that also when the scale is not given. Okay, now let's plot these points. We have point A, 2 and 2. 2 and 2. That means this is my point A. Then I have point B, 2 and minus 2. 2 plus 2 and minus 2. Okay, this is my point B. 2 and minus 2. I have C, 0 and minus 1. X is 0 and Y is minus 1. So that means it's here. 0 and 0, x is 0 and y is minus 1. So that means it's here. Y is minus 1, x is 0. And D, this is not the point. Discard this. This is my C. And D is 0 and 1. So that means it's here. This is my point D. Right? So let me join these points. Now here it is already joined. Both of them lie on the y-axis. But you can make it prominent. Okay, join this also. Then you can join A and B. Okay, then we have to plot the points A dash, B dash, C dash and D dash also. So what is my point A dash? Minus 2 and plus 2. Minus 2, x is minus 2 and y is plus 2. So that means here this is my point A dash. Okay, then B dash is minus 2 and minus 2. So it is here. This is my point B dash. C dash is same, 0 and minus 1. There is no change, right? Because that was invariant. So it will lie here only. And D dash is also same. That means it will lie here only, right? So let me join these now. So you can see from the graph also the points D and D dash, C and C dash, they coincide, right? They lie on the same point. That's why they are called invariant points. C and D, when you reflect these points through y-axis, they are invariant. Okay. Now you name the polygon A dash, B dash, C and D. How will you name this? What is this? Isn't it an isosceles trapezium? Right? So you can write it here now. Fourth part is the quadrilateral is an isosceles trapezium. Right?